All right, welcome back. I am now going to show you how to find the current and voltage drop for each resistor in our circuit. So let's take a look. This is exactly what I had up last time. I've got my total current is equal to 1/7 of an amp. The equivalent resistance for the entire circuit is 84 ohms. So I'm going to work my way backwards through these circuits. And I'm going to be sort of erasing as I go. For this circuit here, I know the voltage drop across this resistor has to be equal to the voltage drop across this resistor. In any closed loop, there has to be this balance of voltage. So if I go up 12 volts here, I have to go down 12 volts here to get back to my starting point. Same thing in this closed loop, I go up 12 volts here, I go down 12 here, gets back to my starting point. So the voltage through the 300 is equal to the voltage across the 116.67, which is equal to 12 volts. Let's look at the 300 first, because that's the one that will actually start to give me an answer here. For the 300, we have the resistance is equal to 300, the voltage is equal to 12, so that means the current is going to be 12 over 300, and that gives me 0.04 amps. For the 116, I'll go resistance is equal to 116.67, voltage is equal to 12, and then current will be 12 divided by 116.67. I'll clarify there. And current through the 116.67 will be 0.103 amps. A good check that I can do is that this current plus this current actually adds up to 1/7, so that works out nicely. So I've got a couple of my answers here. V300 is equal to 12, and box that. The current through the 300 is equal to 0.04, so I'll box that. All right, working backwards a little bit more. Now I've got these two resistors in series, which are equivalent to this resistor here. So that means since they're in series, they're going to have the same current as each other. So the current through the 50 is equal to the current through the 66.67, which is equal to the current through this one. It's equivalent one. And that is all equal to 0.103 amps. Okay. So now I can look one at a time for the, let's go with the 50, since that's one of the ones we're looking for. Resistance is 50. I is equal to 0.103 amps. So the voltage is just going to be IR. So the V through the 50, so 50 times 0.103, that works out to 5.15 volts. For our 66.67, R equals 66.67, I is equal to 0.103, V is IR, and that works out to 6.87. With the exception of rounding, that's these two are going to add up to 12, so that's good. Let's see, which ones did I want? I wanted the ones for the 50. Current and voltage. Okay, let's work backwards one more time. So now we are down to this 66.67. These two are in parallel, so I know the voltage drop across the 200 is going to be equal to the voltage drop across the 100, which will be equal to the voltage drop across its equivalent, the 66.67, which is equal to 6.87 volts. For the 200, I'll go R is equal to 200. V 200 is equal to 6.87. And I will be V over R. And that works out to 0.034 amps. Okay. And then for the 100, I'll go R equals 100. V 100 is equal to 6.87. I is equal to V over R. 6.87 divided by 100. All right. And now we can box the answers we wanted. We wanted the voltage across the 200 and the current across the 200, voltage across the 100, current across the 100. All right. These problems can seem complex, but there's sort of a rhythm to it if you learn how to work backwards, if you learn which voltages and currents are supposed to be equal to each other. They all come together pretty nicely. Let me know if you have any questions.